What's up, Math 8? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 2.5, which is infinitely many solutions and no solutions. This is just day one. Tomorrow we'll talk about another common set, but for today we're just going to determine when equations can have infinite many solutions and no solutions. The first thing we want to understand and copy in our notes are these items here. When the variables cancel out, it's either going to be a no solution or infinitely many today. A no solution means a false statement. That would mean like when you solve and cancel the variables out, you get something like 3 is equal to 5. 3 does not equal 5, so therefore that would be a no solution example. However, if you have a true statement, that would be an infinitely many solutions mark. That would mean like when you cancel out all the variables, 3 is equal to 3 or 5 is equal to 5. Both of these things are true, so that means we would say those have infinitely many solutions. Take time now and pause the video here, copy down what you see, and when you're ready to go on, click play. So what we're going to do here next is try to solve the following equation. Again, we want to try to cancel out variables first. So I'm going to draw my line, and I'm going to try to bring all my variables over here to the left. We talked about that in the previous slide or the previous lesson, 2.4. So if you didn't catch that, go back and try 2.4. I'm going to add 4x to the left side here. So now we have 3, and notice what happens here. A negative 4x plus 4x cancels out, equals negative 7, and the same thing here, negative 4x plus 4x cancels out. 3 does not equal negative 7, so this is going to be not true. So because it's not true, we're going to say there are no solutions for this equation. Okay. Example 2, go ahead and copy and solve the following equations. When you are done, click play to check your work. All right, so in order to figure out how this one works, we're going to distribute the 4 over here first. 4 times 3/2 is like doing this, 4 over 1 times 3 over 2. So that's 4 times 3, which is 12, and 1 times 2, which is 2. So 4 times 3/2 is 12 over 2, or 6x, and then 4 times 1 is 4. So I get 6x is equal to 4, and on the left side I also have 6x equals 4. Noticing that this is a true statement. If you want to, though, you can continue to move all variables to the same side. I can move all variables to the left here, subtracting 6x on both sides, meaning they cancel out. 4 does equal 4, and since this is a true statement, we're going to say this is infinitely many solutions. Okay. Example 3, again, with the same idea, copy and solve the following equation. Try this one for sure on your own if you haven't tried any of them on your own yet. Pause this video now. When you're ready to check it, go ahead and click play. All right, only thing I did here is just move my 2x over here to the left by subtracting. Both sets of 2x's are canceling out here. So I have a 1 or a positive 1 on the left side and a negative 1 on the right side. Since these are not equal, we're going to say there is no solution. Okay. And then example 4, again, copying and solving. Be careful here because right here you're technically distributing a negative 1. Let's pause the video now, try it on your own, and when you're ready to check, click play. So like I said before, this one is distributing a negative, which technically means a negative 1. So everything's just going to change to its opposite inside that parentheses. So I'm going to have 5x minus 3x minus 7 equals 2x plus 8 minus 3. What I need to do next is combine the like terms. On the left side, I have 5x minus 3x, which is 2x. Minus 7 doesn't have anything to combine with yet. And then over on the right side, 2x is the only one, but 8 minus 3 can be combined to make 5. Then I just need to put variables all on the same side. I'm going to move them all to the left side and subtract 2x here. Both 2x's cancel out, so all that's left is a negative 7. Trying to equal to negative 5. This is not true, so we're going to say no solution. Okay. Our last two are going to have a little bit more to do with distribution. Again, let's pause the video here, distribute that 1/2 to the 6t and the 4, then see what type of solution it makes. All right, anytime you multiply something by 1/2, it's also the same thing as dividing it by 2, because when you're doing 1/2 times 6, that's 1/2 times 6 over 1, which is just 6 over 2, and that's equal to 3t. And then the same thing, 1/2 of 4 is 2. So I get 3t minus 2 is equal to 3t minus 2. Right here, you should be able to see that these are equivalent and true to one another. So we can say they are infinitely many solutions. Okay. I didn't even have to move the variables. However, if you did, you could subtract 3t from both sides, and you get -2 is equal to -2, okay? Last example, example number 6, again, pausing this one by yourself, trying it, and then click play to check your work. For number 6, I did have to distribute first before I started to try to get all my variables to the same side. So I have 3x plus 15 on the left side and also 3x plus 15 on the right. Since this is a true statement and they are equal to one another, we can say that there are infinitely many solutions. Okay, that is going to conclude our notes on lesson 2.5 day 1. Tune back in next time to learn about infinitely many, no solutions, or just one solutions. And if this video helped you at all, give it a thumbs up and subscribe. Bye-bye.